Okay, hi again. Today the only thing we're going to do is look at the titration lab that I found online. So let's look at that first and then we'll come back to that. You should have gotten this lab in the packet. Okay? So read through it. The simulation that I'm going to show you follows this actually really quite well. There's a few things we need to tweak, but it's essentially the same thing. This is a burette, and you fill it with base, and it goes from 0 to 50, and it does that because it's always going to show you how much is being delivered. So if I start at 0 and go down to 10.00, it can go to the nearest hundredth by opening this valve here. That tells me how much has been delivered into the Erlenmeyer flask. So it's a little different than measuring something that from the bottom up like a graduated cylinder. And this is, I just put some acid in here just to show you quickly what would happen if you were to add a base like sodium hydroxide. It's not going to show up very long, but maybe you can see that it does turn pink and then it disappears. So what we're really going for here is, if we were to actually be doing the lab, is to have a pink color stay for about a minute or 2 minutes. But if you put too much of this in, and I'll show you that, it will turn it dark pink just like that. So the trick on this is to get close and then it drop by drop. And this simulation does it well. So let's look at the simulation first. I'll leave this up here. I'm going to post this on Google Classroom, and then you can go right to it. So I showed you a little bit of it on yesterday's video. So what you're going to do is select the type of reaction, and we're going to look for, we're going to do a strong acid versus a strong base. We're going to fill the burette with base. The third thing shows you which acid and which base to choose. You're going to choose hydrochloric acid and sodium hydroxide. Those are the same things that we would be doing in the lab. And then the last thing here is, number 4 is select the indicator. They give you the option of methyl orange and phenolphthalein. We're going to choose phenolphthalein. That's what we would be using. Now note here that they automatically give you the volume of acid. It's always going to be 25 milliliters. On this, if we were to be doing this lab in class, I would assign different groups different amounts of HCl, of the hydrochloric acid. So assignment 1 would be 10, then 15, 20, 25. So in this, because we have to go by what the simulation does, the molarity is going to be the same. Excuse me, the molarity is going to be given to you. This is what we would be looking for. The molarity is going to be given to you, and what we're trying to find is the volume of the sodium hydroxide. The volume of the HCl in the simulation is going to be the same. It's going to be 25.0, 25.0. So I'm going to have you do 2 of these. Okay? Don't worry about trial 1 or trial 2. So this is going to be 25, and that's going to be 25. And the molarity is going to be given to you. So let me show you that. Down here, here's the volume of the HCl, 25 mils. And here's the molarity. That's 0.1827. So on my sheet, I would put 25 milliliters. My molarity for me would be 0.1827. So, when I'm done with this one, if I don't mess it up, that is going to, and I do my second one by resetting over here, that is going to reset. Okay, I'll show you. So the first time it was 0.1827. I want to reset it and do everything again. Strong acid, strong base. I'm putting base in there. I want hydrochloric acid and sodium hydroxide. And look, they've changed the molarity of the acid again. But it's still 25 milliliters. Okay? Just as a hint, the lower the molarity, the less it's going to take of the base. Now here's the tricky part, and I've got to sit in my chair in order to do that. You have to move this bar to allow the sodium hydroxide to come in and then change the acid. Now, that is tricky. So when you get close, you're going to start pushing that button that says dropwise. So let me show you. If I were to dump a bunch of it all at once, and it will show you, of course it's glitching, I'm going to reset it quick. You can see that the molarity has changed again of the acid. And let's see if I have it. Okay, so something's glitching here. Hold on. Let's try it again. Oh, maybe I'm not hitting, I probably didn't hit the phenolphthalein. Okay. So here's the molarity again at 0.1211. So this is changing. You can note that the volume is not changing. So make sure you do hit 4, otherwise it's probably not going to work. So, yes. So this will show you how much is being added. Now watch. Down here, it's going to turn pink pretty quick, and I can keep adding until it starts to fade. Still nothing. Okay, did you see that? If I add just a little bit more, all right, so once you get that, you're going to want to, and it's going to take some time, you're going to want to hit dropwise until it turns pink and stays a faint pink. If you go more than that, and this you can do about once every second. It shouldn't take more than 2 or 3 minutes though. Now every time that I'm dropping here, you can see that it's changing by 2/100ths of a milliliter. There it is right there. I almost went too far. Okay? So at this point, I've reached my equivalence point. So what do I do here? Now I'm going to use this information, this one, not over there, this one, to figure out my volume of the base. So again, that is MAVA equals MBVB. The molarity of the acid is here, so I would put 0.1211 molar. And the volume is going to be the same at 25.00 milliliters. I'm going to bring it down a line because I'm moving over to the side a little bit. The molarity of the base is my unknown. And the volume of the base tells me 18. And that's 18.00 milliliters. So then I would solve for that by bringing the 18.00 milliliters below this. Cross out my milliliters. And if I get a calculator, I can figure that out pretty easily. 0.1211 times 25 equals divided by 18. 0.168. We'll go to the nearest thousandth on this, that's fine. Okay? So, what would it look like on my lab? Volume 25, trial 1 volume, I figured it out. Oh, I didn't figure it out. It was 18.00. So I would put, this is 25.00. This is 18.00. We don't have to worry about trial 2. We won't do the average because it won't apply. And the molarity of the HCl for me is 0.1211. Okay? So, essentially that's it. What we really should do is change this one into, actually let's do that, change this one into the molarity of sodium hydroxide. Okay? So on this paper, change this to, you can cross it and just write it in hand, molarity of the sodium hydroxide. All right? And I just calculated mine as 0.168. And that would be big M for molarity. Okay? So, do 2 trials of that. Now, I'm also going to show you what happens if you add too much. If you put a bunch in all at once, just dump a bunch in. If it turns this color, you've gone too far. You've gone too far with that, and it's not going to be as accurate as it could be. Okay? All right. The other things here, I put together packets for the next unit, and in that packet, which is, excuse me, it's on organic chemistry. We'll do the videos every day. Mostly it's naming, and then there are some reactions that go with that, but a lot of it, most of it is naming things. And also what's in there is the test for this unit, for Unit 8. So that's coming home. It should come home today. I'm going to have it due on Thursday by noon. However, I'm going to make a Google Forms sheet. I'll put it on the assignment on the Google Classroom. You put all your answers on the Google Forms sheet, okay? Don't take pictures and send it in this time. Use the Google Forms sheet and put your answers right in there and then submit it, okay? Then when I go through them, we can figure that out. I'm also going to set up a Zoom, and I think some of you have already used it. But most likely I will put on Google Classroom. I'm going to try for tomorrow at probably 10 o'clock because that seems to be free. If not, I'll let you know. I'll put it on Google Classroom. All right, look at this video.